Hello friends, welcome to my channel. Today is the day 30 for our PCNSA series. In my previous video, I have covered about certificate, how exactly it works, what is self-signed certificate, and I have talked about lot of understanding and the concept about the certificate. So I'll recommend you guys to please watch my previous video. I will put the link in the I button so that you can click and you can watch that particular video. Okay. In this video, we are going to understand a little bit more about SSL communication. So to understand SSL, we have to understand what is encryption, what is hashing, what is DH and authentication. Okay. And then we are going to understand how basically SSL handshake works. So let's say we have a PC and when we are connecting to a server through HTTPS, what are the negotiation which takes place? So we are going to understand that in a negotiation way. What are the messages gets communicated? And also we are going to see if we have a Palo Alto device in between, how can we decrypt the traffic and how Palo Alto checks the traffic and sends to external servers. So this is very important concept that we are going to learn today. That is the reason I'm asking you to please, or I recommend you to please watch this video till then. That will help you to understand the concept. Also it will help you in the interview course as well. Okay. And also I'll request you to please subscribe my channel and hit the bell icon so that you never miss any video from me. So without any further delay, let's get started. Hello friends, welcome to my channel. Today is the day 30 for our PCNSA series. In my previous video, I have covered about certificate, how exactly it works, what is self-signed certificate, and I have talked about lot of understanding and the concept about the certificate. So I'll recommend you guys to please watch my previous video. I will put the link in the I button so that you can click and you can watch that particular video. Okay. In this video, we are going to understand a little bit more about SSL communication. So to understand SSL, we have to understand what is encryption, what is hashing, what is DH and authentication. Okay. And then we are going to understand how basically SSL handshake works. So let's say we have a PC and when we are connecting to a server through HTTPS, what are the negotiation which takes place? So we are going to understand that in a negotiation way. What are the messages gets communicated? And also we are going to see if we have a Palo Alto device in between, how can we decrypt the traffic and how Palo Alto checks the traffic and sends to external servers. So this is very important concept that we are going to learn today. That is the reason I'm asking you to please, or I recommend you to please watch this video till then. That will help you to understand the concept. Also it will help you in the interview course as well. Okay. And also I'll request you to please subscribe my channel and hit the bell icon so that you never miss any video from me. So without any further delay, let's get started. So friends, before we understand the SSL handshakes, we need to understand some of those topics, which is basically very much important during the negotiation of SSL handshake. So the first thing that we are going to understand is encryption, hashing, DH and authentication, right? So with this all images, we are going to understand more about them. Okay. So encryption is nothing but it is basically changing the plain text into a cipher text, so that if somebody takes the data in between, so let's say if you are here, it's your source and you are sending the traffic to the destination, if somebody takes your data, they cannot read what you're sending it, like it's not in the plain text basically, right? In the hashing, what happens is it basically does not change the data. Okay, it's not changing the data. Instead, what it does, it basically creates a hashed text. Okay, now in the hashed text, what happens is it basically attach with the data. Okay, and this text, let's say for an example, I'm just taking a text as hello. Okay, so now with hello, the hashed value is very random. So this is hash 157 a b, something like this, right? Now if somebody changes that data to hello 1, now this the hash value will also get changed. Now this hash value get attached with the data in between. If some hackers changes the data and sends the data towards the destination, what exactly happens is the destination will also use the same algorithm to check the hash, right? So if somebody has modified the data, now hash remains the same when it reaches to the destination. Okay, now with the modified text, if he runs the hash function, he gets the different hash value. So what is attached with the data, it is not matched with the new hashed text, it will be discarded. So meaning that nobody would tamper or nobody would modify the data during the transit of the traffic from source to destination. So hash ensure that. Okay, now after that we have something called as Diffie-Hellman, which we call it as DH. Now in Diffie-Hellman, it's a key exchange algorithm, right? Let's try to understand. Okay, so I'll just remove all this. I'll take a source and I will take a destination. So in DH, what happens is it basically generates a private public key. So this is private and this is public, this is private and this is public. Now the private will stay at the device, okay, and public will be exchanged with both of them. Now they will go for a calculation. You can just go through this particular image, you can take a screenshot and you can understand, or maybe you can go to some of the documents, you can understand in a detailed way. If I start covering all those mathematical calculation, it takes a lot of time. Okay, so they'll exchange the public key each other. Like as you understand, if you basically correlate with the public and private key, basically there are few talks in your family. It can be a private, it can be a public. Public can be speak to anybody, but private, it should be inside the family itself. So same way, private key should not be shared, only public key will be shared to each other, right? So they'll exchange the key and they will go for some mathematical calculation, and they will generate same key in the both the places, right? So this is how they will go for a calculation and they will retrieve the same number. This is the beauty of Diffie-Hellman calculation, right? So you can just go through all this. This is just a summary that I have told you to make you understand. Okay. After that we have authentication. Authentication is basically, there are two types. One is we can call it as pre-shared and another is called as digital certificate. Now pre-shared is basically you are putting the password here. Let's say I am putting as password and I'm putting as pass. So I'm using the same password here and there. But in digital signatures, I'll have my identity and I have my identity. I should be trusting to somebody else. If I trust this and if he trusts this, we will be able to authenticate ourselves basically, right? So there is a way to identify ourselves that we are the person that you supposed to connect, or we are connecting to the right destination as well. So authentication ensures that. So when we are sending the data on internet, it should be encrypted, it should be hashed, the key should be exchanged, or key should be used to encrypt and decrypt, as well as there should be a way to identify ourselves. So these are the parameters that you have to take into consideration when you are doing an SSL handshake understanding, right? So let's explore how SSL understanding works. SSL handshake works. Okay. So friends, now we'll understand what is SSL handshake. This is also very important to understand where that SSL decryption happens. So we need to we need to understand how SSL works, then we can understand the decryption. Okay. So with the help of this particular image, we'll try to understand more about it. Okay. So for an example, let's take a scenario. This is your PC. Okay. And you are going to connect to a server. Now server is google.com, right? So your PC is trying to access www.google.com. So it will not directly go. The first thing what happens is the DNS resolution, right? Once the DNS resolution done, then he gets the IP address, right? And then the TCP handshake happens, like the three-way handshake. Okay. So after three-way handshake, after that the SSL handshake happens. Now in SSL handshake, now why the handshake is happening? Like they will agree on some parameters and then they will exchange the data. So still here the data is not flowing from PC to google.com. Here also the data is not flowing. Here also the data is not flowing. After this communication happens, like it get finished, then only the data will start traveling, right? So you need to understand what are the processes happens before HTTPS or SSL connection, right? So let's understand and let's start with step 1. Now in step 1, what happens is the client will send a hello. He will say that I want to make a SSL connection with you. Are you ready? Now in this particular SSL connection, what happens is he will be sending whatever the PC supports, the encryption algorithm, the hashing algorithm, the DH algorithm, and the authentication method. Okay. Now whatever server support, like in server side, whatever they support, like whatever the server support, he choose that algorithm and he responds that I am going to continue with, because PC will have like for encryption 5 let's say for an example 5 encryption algorithm it supports. Hashing he supports 7 algorithms. In DH it supports 7, like that. So every all these policies will be going to the server and server will choose what he supports, right? So once he replies to it, so he sends a hello from the server side. Okay. And he will share his certificate as well to verify that you are connecting to google.com or are that particular, whether you are connecting to the right server or not. So with the help of certificate, we'll verify that. Okay. So he gets the certificate from the server. And also I was talking about the DH. So in DH, what happens? They generates a public and the private. So he'll be sharing his public key on 4th message and he will say I am done with my messages. Okay. Now after that the client will also generate public, private and public keys. Now he will be sharing the public key. Okay. Now public key of the server and private key of client, and vice versa, the private key of server and public key of client, they will go for a mod calculation, that mod mathematics calculation, and they'll generate a number. Let's say it is 100. So both sides, they will generate the same number itself. And after that, the PC will say that we are going to use this particular key for our further communication. So encryption, decryption, whatever that we are going to do further, we will be using this particular key itself. We are not going to use any other key. Okay, so we are going to use no certificate, nothing is there. So we are going to use this particular key. Now, that is the reason it is just informing that we are going to use this particular key, and he will done with his messages. Now, he will verify, like he will be sending a messages in this particular that we are going to use this key. Now he will verify whether I am also using the same key or not. So he'll also verify and he will acknowledge that yeah, we are going to use this particular key, whether you are having the same key or not. So they will verify each other. Okay, and after that it will be done, and then the data travel will start after that. So basically what happens is, if you see this, they will be using the same key for encryption and decryptions. Now this key is also known as session key. So if this key gets compromised, like your session gets compromised, as simple as that. So session key is very much important. Okay, and session key will not be able to calculate by anyone, because nobody will have the private key, because private key will never be shared between client and the server, only the public key, right? So this is how the whole communication of SSL handshake happen. So in SSL handshake, it's very easy to understand. Algorithms are going, accepting, sharing the certificate to verify whether you are connecting to the right web server or not. He's done. He will exchange his public key. He will also exchange his public key. They will generate a number. They'll share the number and they'll say that they are going to use the same key, both the sides. And after that, the data start traveling. Okay. So this is the whole process of SSL handshake. Okay, now how Palo Alto will do the decryption, we are going to see in this. Okay, so friends, now we'll understand how SSL decryption works actually with the help of this particular image. This is very much important thing that we need to understand, and you guys need to remember how SSL handshake works and what is this. Okay, now as I have explained about SSL handshake, let's understand the SSL decryption here. Now, the first thing that we have to keep in mind that we have to have either a CA certificate or a root certificate into Palo Alto Firewall. We need it first. Okay. Now the second thing is, Firewall will maintain a connection between client, like this is connection 1, and also it will maintain another connection with external server, which is like, let's say google.com, right? So we have two connection with respect to firewall, but from client perspective, this is only one connection. From Google perspective, only one connection. Okay. This is the basic foundation of understanding SSL decryption. Okay. Now let's understand further on this. Now here is the thing. I'm not going to explain the whole SSL handshake over here again, but I'll just give you an idea what exactly happens. Okay. Now let's say for an example, the SSL client wants to initiate connection towards google.com. Fine. Now in google.com, what exactly happens is, first DNS resolution, then TCP handshake. Okay. and then the SSL will happen. Now during the SSL, the first traffic will be moving from client to Palo Alto firewall. Okay, once it moves from client to the server or the Palo Alto firewall, it basically creates a new connection with google.com. Okay, so the Palo Alto firewall will create a new connection. It's a connection. Now he will take that Google, client wants to go to google.com. On behalf of client, it initiates a new connection to server like the google.com. Now Google will respond him, like during the first message, the encryption algorithm, all those things will be there. The firewall will just copy all the information and sends to the google.com, and the google.com will respond by selecting the algorithms and the certificate. Now the certificate from the google.com. Now he takes the certificate and on the fly it generates a new certificate. So generates a new cert, and what it does is it copy all the information, like it copy all the information from Google, all the information, and put the information issue by Palo Alto. Okay, because it's a root. So CA or root certificate can issue certificate, as simple as that. So it basically issue a new certificate or basically creates a new certificate, and this certificate will be sent out to the client. Got it? So what is happening? He gets the certificate from Google, he generates a new certificate, and that certificate will be shared to client. Okay. Now to make that certificate trustable to the client, the root CA certificate has to be there in the client machine. Okay, I'll show you how to import that certificate, how to install that certificate in the lab. For now, you just understand that to make it trustable, we have to have a certificate inside this client machine. Otherwise, you will see throwing an error in the browser that I don't trust, because this is just a self-signed certificate. Okay, or we can buy a certificate from outside. There is no problem. We can do that as well. So for that reason, it should be trustable. We don't need to import the certificate over there or any because it's a public certificate in that particular case if we buy it. Okay. Now in this case, what is happening is it generates a certificate or creates a certificate and sends to the client. Now here there will be a different SSL handshakes will be happening, and here the different SSL handshakes will be happening both ways. Okay, so after all this, there will be a different session key here, there will be a different session key here. Okay, so what happens is when the client wants to send any traffic, what happens is it encrypts the traffic. After that, it goes and decrypts the traffic, because the connection ends here. He checks what is there in the traffic. Okay, and then he encrypts the traffic and sends to the google.com, where he decrypts the traffic. So it basically happens 2 times, encryption, decryption. So it basically works as man in the middle, as simple as that. Because he needs to inspect the traffic, what is happening. Let's say for an example, right now you are your machine is going to google.com, which is fine, which is basically a well-known site. There is no problem going over there. But if your machine is going, or the clients or the employees or the users inside the organization wants to go to a server which is not very much popular, or there is no chance of knowing that particular website itself. Okay, now website can inject malware, or if you are going to that particular software, access that website and something goes wrong in that particular case, if you are not decrypting the information, you will not get to know. The firewall will never get to know what is happening, because it will be encrypted from here to here. It is end to end encrypted. That is the reason the firewall will come in between and works as man in the middle, and it basically maintain a connection between firewall to the client and client to from firewall to the external server. It can be any web server. Okay, so this is what exactly happens in SSL decryption. So guys, this is what I wanted to cover in this particular video, and thank you so much for watching this. If you have any questions or let's say any suggestion for my video, you can just put it down in the comment box, or you can reach out to me on Instagram, Facebook, wherever you want to reach, or maybe you can send an email as well. Thank you so much for watching, and I'll see you in the next. And don't forget to subscribe and hit the bell icon so that you never miss any video. Thank you.